will discuss the NP-Completeness of Hamiltonian cycle problem. The Hamiltonian cycle problem basically is given an undirectly graph G and asks whether there exists a cycle that visits every vertex exactly once and returns to the starting vertex. Such cycle is called a Hamiltonian cycle. To prove that the Hamiltonian cycle problem is NP-complete, first we need to show this problem is in NP. So the certificate for Hamiltonian cycle problem is a specific ordering of verification. So the verifier checks whether each vertex appears exactly once in the sequence and verify that each consecutive pairs of vertex in the sequence is connected by an edge, and the edge connect the last vertex to the first. We know the time complexity for this verification is OV plus E, which is polynomial in the size of the graph. Therefore, the Hamiltonian cycle problem is in NP. Second, I will use reduction from three-set problem to Hamiltonian cycle problem to show it is NP hard. I will construct a graph such that a Hamiltonian cycle exists in the graph if and only if the original three-set formula is satisfiable. For this three-set formula with three clauses C1, C2, C3, I will construct four variables x1, x2, x3, x4 with 6 nodes each that correspond. So the four variable paths P1 to P4, and all the paths can traverse in two ways, one corresponding to the variable being true and the other corresponding to the variable being false. So the edge from left to right on the path is corresponding to assignment that is true, and the edge from right to left on each path that's corresponding to this assignment is false. So we need to add edges to allow movement between variable passes, and notice on the variable passes to ensure all the variables are visited. Then we connect source node and the target node to the passes, then add a back path from the target to source so that this path will always be present in any Hamiltonian cycle of the graph. Next, we need to connect paths and clause. If clause Cj contains variable xi, we need to connect the Cj to node 2j minus 1 and node 2j. So C1 need to connect to nodes 1 and 2 in each path. C2 need to connect to nodes 3 and 4. C3 need to connect to nodes 5 and 6. Also, if the node contains the negation of the variable, we need to connect right to left. Otherwise, we connect left to right. So for example, for C1 contains variable x1, so we need to connect node 1 to C1, then connect to node 2. For C2 contains the negation of x2, we need to connect we need to connect 4 to C2, then from C2 to 3. Now we have the constructed graph. If we highlight it in red, we can see the path is continued and the graph G has a Hamiltonian cycle. And we can see x1 is true, x2 is false, x3 is true, x4 is false. So the cycle traverses through the nodes corresponding to the assignment that satisfy our all clauses in the three-set formula. Therefore, any instance of the Hamiltonian cycle problem can be reduced to an instance of three-set problem. And we can conclude Hamiltonian cycle is NP hard. Since we proved Hamiltonian cycle is both a NP problem and a NP hard, we know Hamiltonian cycle problem is the NP complete